You're looking at live pictures of the sky above the Utah Test and Training Range. In less than an hour, a 4.5 billion-year-old piece of the ancient solar system will be landing here in the desert. This is live coverage of NASA's OSIRIS-REx sample return.
There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Welcome and thank you for joining us live from the Army's Dugway Proving Ground in Dugway, Utah. This is special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space. I'm Lauren Ward, and joining me is Dr. Jim Garvin, Chief Scientist at NASA's Goddard Space Flight Center. He's a planetary geologist by training and also probably one of the most excited people around here today.
Lauren, literally, I'm over the asteroid.
Better than over the moon, over the asteroid. Well, I'm excited to share the stage with you today. We've got a lot to discuss and a huge adventure straight ahead. And for those joining at home, Jim and I will be taking your questions live throughout the show. You can send those our way by using the hashtag AskNASA on X, YouTube, and Twitch. And if you want to follow along this final guide from the mission at home, scan the QR code on your screen and check out NASA's Eyes on the Solar System, where you can view a complete 3D simulation and follow the OSIRIS-REx sample return capsule to the ground. And during the broadcast, you'll hear directly from the mission team, so listen very closely for those operational callouts. Before we get into the action, though, tell me, Jim, what are you most excited about?
Lauren, it's the masterpiece of engineering we have here. Just think about this. In 50 years, we've gone from bringing things on the moon back with crews to all robotic sample return for science that's literally beyond words. It's sublime. So we can't wait to see what we're going to learn.
We cannot wait. So OSIRIS-REx is an acronym for Origins, Spectral Interpretation, Resource Identification, and Security, Regolith Explorer. Yes, it's a mouthful, but the mission describes an audacious objective. Send a probe on a long journey to an asteroid, map it, grab a sample, then bring it back to Earth for analysis. Following launch on September 8th, 2016, the plucky probe took an extraordinary route through the solar system until it reached the asteroid Bennu. Then, after more than a year of mapping the surface in exquisite detail, OSIRIS-REx made a careful descent in October 2020 to collect a sample. 3 years later, we are here at Dugway Proving Ground in the deserts of northeast Utah, awaiting that capsule containing the sample, which experts tell us is essentially a time capsule of the ancient solar system. We've got a great team joining us this morning as we experience this thrilling conclusion of this grand adventure. Sophia Roberts is located near our landing zone, and she'll be speaking with some key players in the mission. We'll also hear from James Traley, who will be tracking mission operations and bringing us real-time updates, essentially our eyes and ears inside mission control, which sounds to me like a good place to jump into the story. James, good morning. How are we looking?
Yeah, good morning, Lauren and Jim. It's already been a very bright early morning for all of our team members involved in this mission. Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft. And I'm very happy to report that they gave the green light, they gave the go command officially to release the SRC from the OSIRIS-REx. Let's listen in on what that command sounded like. That command came after more than almost 4 billion miles of spaceflight and years of planning, plotting, and dreaming about this asteroid Bennu. The SRC has now been separated from the main OSIRIS-REx spacecraft and is coming in rain or shine today. So team members are keenly aware of the weather conditions out on the range. It's looking pretty great for today. We did have a bit of rain the other day, which softened up that landing spot just enough to make the SRC land perfectly smooth on that surface. The temperatures are going to be around the 50s, 50 degrees Fahrenheit. Low winds out there, calm winds at the surface around 6 miles an hour, pretty light. Very clear skies this morning as well. As we were actually driving out, I saw a shooting star, a meteor, and in just a few moments, the SRC itself will be streaking across the skies as we begin to track it. Just a few moments ago, we We heard the helicopters take off from here to head out to Wig just at the edge of the landing ellipse. Our high-altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. But for now, back to you, Lauren and Jim.
All right, thanks, James. We'll be back to you for mission status updates throughout the morning. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. In less than an hour, the sample will touch down in our landing ellipse at the Utah Test and Training Range, managed by the Air Force, about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us, where the sample will end its journey today. Tomorrow morning, a C-17 aircraft will take off from the runway behind us and deliver the sample to NASA's Johnson Space Center in Houston.
Unbelievable.
Unbelievable.
Can't wait.
Oh, gosh. I can't wait to see that C-17. Oh, that's going to be breathtaking. We have a lot of ground to cover, and we'll be bringing you into the heart of the action. For all of NASA's many missions over the years, OSIRIS-REx lives in an extremely rare category. It not only ventured out into space with cameras and sensors, but it's bringing a physical sample of the ancient solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination. Following a successful touch-and-go procedure to grab a sample on October 20th, 2020, OSIRIS-REx has been making its way back to Earth. It's been a thrilling ride already packed with technical achievements and scientific discoveries. Today's historic landing continues that saga, promising exciting research ahead. Beside our main event this morning, we've got a ton of extremely cool stuff. We'll hear from a special guest astrophysicist whom you probably recognize more for his chart toppers. We'll speak with one of the helicopter pilots about his role in getting recovery teams out to the landing site and bringing the capsule back home. And we'll even hear from the cast of the film Asteroid City. And of course, we'll give you a front row seat to the mission itself, the science, the engineering, and why a mission to gather space rocks, well, rocks.
Right?
NASA's first asteroid sample return happens in less than 35 minutes. Let's now take you to Wig Mountain, where our field reporter, Sophia Roberts, is standing at the forward edge of the vast landing zone where she joins us live now. Sophia, paint us a picture.
Lauren and Jim. Now, it is a bright and chilly morning, but the excitement certainly is rising. Now, let me give you a lay of the land of what is going to happen today. The sample return capsule is going to hit the top of the atmosphere at approximately 8:40. It will descend through our atmosphere for 13 minutes before touchdown. Once it does touch down, our team with the recovery team will go to the sample or the capsule and start that carefully rehearsed recovery process. Now, I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive. Back to you, Lauren.
Wow, Sophia, I think she has the best seat in
Oh
the
my
house.
God, take me there.
I want to go there. All right, let's get some quick facts about the OSIRIS-REx spacecraft. Filled with fuel, the vehicle weighs more than 4,600 pounds. That's about the same size as 3 large cows. Did you know that, Jim?
I did not, and I'm afraid of those cows.
Let's stay away from the cows. With its solar arrays extended, the spacecraft is about 40 feet long, or the size of a short school bus. The solar arrays can power up to 3,000 watts, which is the same as a portable generator. Once on Bennu, the 11-foot robotic arm collected dust and pebble samples, while the cameras got up-close images of the asteroid. How about that? And then, of course, there's the SRC, or the Sample Return Capsule, the capsule that's separated from the main vehicle and is currently on its way to our landing zone in the Utah desert. So, Jim, I think importantly, the team can't just open up the capsule right on the desert floor, right? What happens next?
So next, we have to safe it, we have to bag it, we have to contain it, and transport it to the clean room about a mile from here. And in that clean room, we will actually bring the sample return capsule in, take off the back shell and the heat shield, and carefully arrange to nitrogen purge that special sample container inside, so it does not introduce any contamination from Earth, because we want asteroid, not Earth.
That's right. And I love missions like this because I find my own imagination just bursting with possibilities and questions. And so with about a little bit more than 30 minutes to go before the SRC hits the top of the atmosphere, we're going to take a few minutes to dive into the nuts and bolts of the mission itself. We've got a great mission overview to help explain. Take a look.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Wow, I get chills every time I see that.
Me too.
Amazing. All right, so we know you have questions, so please continue to send them to us using the hashtag AskNASA. But before we go any further, I've got a question for you, Jim. Why is the mission called OSIRIS-REx? It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird deity, but it means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water and hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning we'll be taking questions submitted via social media. So let's take one now. All right, what do we have? At S4Mule_B asks, what's the significance of studying asteroids like Bennu for advancements in planetary science?
These are literally the time capsules of the early solar system with those bits and fragments we can never get here. So we go and bring them home to connect ourselves to the place we live, our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have? All right, from at Ndanger817. Approximately how large is the sample size, and what kind of analysis will be performed?
So it's about 8 or 9 ounces. It's about a size of a baseball and a half, and the kind of analyses are amazing. There are toolkits and instruments that can look at nanoscale characteristics that you wouldn't imagine. We could see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning. Okay, so let us head back to the ellipse to talk to Sophia. I understand, Sophia, you've got a critical team member with you. Take it away.
Thanks, Lauren. Yes, I am joined right now by Stu Wiley, who is the Oscar, or on-scene commander, of this recovery mission. Thank you for joining me, Stu.
Thanks for having me, Sophia.
All right, so you are the person who kicks off this whole process before even the recovery team gets on the ground. Can you walk us through your process?
Yeah, so essentially what's going to happen is that once the capsule is undershoot, we'll have a better idea of where it's going to land on the range. And based on that, I'll know exactly what kind of weapon systems we used in that area, what kind of tests we've done in that area. So I'll know better what kind of hazards are in the area. Once I land on the ground, I'll do an initial sweep of the area and methodically move towards the capsule and mark any kind of hazards that I find, whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capsule, and they're more familiar with our terrain here as well. Yeah, so.
And this is an active proving ground here. So what are the other steps that we have to ensure that our teams are safe?
Yeah, so at the Utah Test and Training Range, we do have a lot of different hazards out here. Like I said, the weapon systems that we test. We're going to keep them safe from that. We have, again, done many of the preparations with them already. They've taken safety briefings. They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world. One super fan in particular is a well-known astrophysicist with an atypical side hustle. But I'm guessing you know him probably more from his side thing than his science thing.
Well, that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know probably, but also immensely proud to be a team member of OSIRIS-REx. I can't be with you today, I wish I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission. Especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning.
Great to have you here, Lori.
Great to have you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Lori.
Thank you.
It is a really exciting day. So OSIRIS-REx is part of a larger autumn for asteroids, asteroid autumn, as we've been saying. Can you talk about some of the other missions that are happening this fall?
Happy to do that. It is really exciting. We have lots of asteroid missions, and actually 4 of them have major milestones coming up this autumn. Right on the heels of the sample return happening today. In 2 days, On September 26th is the one-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test, demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow.
Wow, check that out.
It literally is an asteroid arm. But Lori, one other thing, OSIRIS-REx, is a multi-purpose mission, all this great stuff you mentioned, and one of its key jobs is to help us with planetary defense. How does it do that? Way out there.
So actually, OSIRIS-REx gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space. And that actually kind of acts as a force that kind of pushes back against the forward trajectory. And so it changes our predictions on where the asteroid might be. Over time, it really makes a difference. And OSIRIS-REx gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the planetary defense aspect more than me and Jim.
Yeah, we want to be safe.
Big fans, big fans. Really quickly here, this isn't the end for OSIRIS-REx. What's next?
Yeah, so really exciting. Now that the spacecraft has released the capsule successfully, about 20 minutes after that release, we're now repurposing the spacecraft for a new mission called OSIRIS-APEX, where APEX stands for Apophis Explorer, and it's off on its new mission to explore the asteroid Apophis, which is going to have a close flyby of Earth in 2029.
All right,
Lori.
Stay tuned, everybody.
Unbelievable.
That is fantastic. Well, thank you so much, Lori, for
Thanks,
joining
Lori.
us. You're going to stick around for the show, right?
Oh, absolutely.
Absolutely. Okay. This will be the biggest U.S. sample return since the Apollo mission to the moon. But this is not the first time that anyone has captured a piece of an asteroid. On the arrival of the historic OSIRIS-REx sample, we celebrate that the Japanese Space Agency, or JAXA, has already visited 2 asteroids, Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to James for an update on mission operations. Go ahead, James.
Yeah, thanks, Lauren. So everything continues to be nominal. I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. He's ready to go. He understands the mission. They are ready to get out and recover that sample today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours ago at this point now, the SRC was released from the main OSIRIS-REx spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown today. What you're about to see is basically the equivalent of throwing a touchdown pass over 10 football fields away and landing it perfectly in that end zone. So you can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitoring the vitals of the SRC all morning. They've been there in the room, prepared and ready to go. I'm sure they are absolutely thrilled for this moment. They might even see themselves on the screen there in a second, but they are hype and ready to go. This is the Lockheed Martin team just a little bit north of us in Waterton, Colorado. They are also dialed in. They're the ones who gave that initial command this morning to release the SRC from the main OSIRIS-REx spacecraft. You just heard from Lori that OSIRIS-REx is now on its way to its extended mission. OSIRIS-APEX visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
Thanks, James. Very soon, NASA's Artemis program will be bringing us more cosmic samples to study by visiting a familiar beacon in the sky. Give us 60 seconds, and we'll give you the moon. Artemis 3 will be the first sample return mission of NASA's Artemis program, sampling rocks and regolith from one of 13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid Bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Oh, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
Yeah, big moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft is not coming back today, right? It's just a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus, but this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This this is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies, the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent, to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is. And it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to the Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation. Wow. We have a science team led by the University of Arizona. And then we have
recovery operations. Helicopter 1 has departed wing to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science and expert on how our planet works in climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice, to being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right, well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because of its
Recovery operations. Helicopter 2 has departed WIG. The station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
progress. Fantastic. Woo. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it. But right now, we are waiting to hear precisely where the capsule is going to land before the rest of the teams head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here so we're ready to transfer it tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today, period of a few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. Those colleagues, in a special clean room perfectly designed for this mission, will unpack those precious samples in the small sample canister, the small device that was used on the end of the TAGSAM, and they will go through a process to get it checked out, to do early reconnaissance, and to protect it very carefully.
That is incredible, and they built that whole clean room. No other asteroid samples before.
Right.
This is the first one.
First ever.
First ever. As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple call-outs come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning, scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone will be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within, that just a few years ago was on the other side of the solar system from us sampling at Asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
EDO milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of Asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL milestone. We have touchdown. I repeat, EDL SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and potentially the origins of life. We're not in the clear just yet. A key piece of the mission is about to get underway. This is the recovery operation phase. Once the team has officially confirmed the exact touchdown location, they'll be flying out on 4 separate helicopters and will operate much like a Formula One pit crew, if you will, to recover the SRC, take environmental samples at the landing zone, the LZ. Everyone has a role to play. It's going to be simultaneous action as they get that SRC recovered and begin to do an environmental safety sweep, collecting samples along the way. You see our mission ops team just next door. Once again, remind you that the sample canister itself is not actually going to be opened here at Dugway. The next phase of the operation is simply to get that SRC into the portable clean room that has been specifically set up for this recovery operation. The team will then remove the heat shield protecting the SRC and its precious cargo within the entire descent through the entry, descent, and landing, remove the back shell, and then extract the sample canister within the tag SIM that just a few years ago collected pieces from the asteroid Bennu. Today, the goal is to get the sample canister.
Recovery operations. Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery operations. Stu Wiley, our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any possible dangers that would be presented to them as they begin those recovery operations. And then a team member from Lockheed Martin will begin to take gas and thermal readings once the area is safe of that SRC to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts, and you'll see them walking out to that sample in just a few moments here once those helicopters land. A great view once again from our high altitude plane. You can see the parachute there next to our SRC. There is a possibility that there could be unexploded ordnances from that parachute. There is a mortar inside that is to fire to disconnect the parachute from the main SRC to help it come to a final rest. It's a bit challenging to see from this perspective, but there could be some potential roll marks or skid marks as that SRC came to a rest on the rugged desert surface below. As I mentioned, we did have a bit of precipitation here the other day, so that should make for a nice soft surface for that SRC, so it probably had a nice clean landing there. The team will assess as they get out there and check exactly how our conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample. And this is a pristine sample from the ancient solar system and could hold the clues to how everything around us came to be, from the formation of the planets to the origins of life here on Earth. Needless to say, this is precious cargo, and the recovery team is fully aware of the gravity of the situation and the importance of what they're about to do today with these recovery operations. You can see it looks like our parachute has come to a stable rest. The winds were pretty low today, so it looks like it is not billowing at all. It is almost perfectly flat, at least from this perspective, on that desert terrain. And throughout all these operations, the crew member safety is paramount. So you'll see the team probably huddle up a couple times as they begin these recovery operations to make sure that everything is safe and continues to be nominal as they make their initial safety sweep. All of this recovery should be a very quick process, usually. They've rehearsed for this again for months. They've been out here all summer really rehearsing for this moment. They did a drop test last month. They've also had numerous rehearsals actually practicing containing that SRC, getting it on a sample carrying fixture.
Recovery operations, WB has located the parachute on the ground.
You just heard that confirmation from that high altitude plane locating that parachute on the ground. This location info will be relayed to our team members aboard those helicopters as they begin their approach out to the landing zone. We do have that confirmation from the high altitude plane, as you just heard. We're still working to get confirmation from our NASA helicopter. It is on its way out to that landing zone as we speak, so we should hopefully have that view up in just a few moments. You continue to see our team just next door, the mission operations team, all looking at that high altitude view. Right in the middle there, just pointing around with the UV white shirt, is Rich Witherspoon from Lockheed Martin. He has been leading a lot of these operations for the past couple months. He's been preparing the team for this exact moment and really has been a great leader, helping us get ready for these recovery operations. Yeah, so this ellipse here, this landing zone, is a quite large setup here, and this was chosen intentionally for this mission. It's about 37 miles by 9 miles total, this landing ellipse, out in the Utah Test and Training Range here in Dugway, Utah. This is an enormous facility. As you heard earlier, it's about the size of Rhode Island, all in all, this whole facility. It's relatively flat, very smooth terrain, this desert surface. So it's perfect for bringing something back and having that nice, safe landing on the desert surface. Just a few years ago, the OSIRIS-REx spacecraft back in 2020 made its tag attempt, the touch and go attempt to actually collect the sample that has now landed in this desert. When it did that, it was only at the surface for just a couple seconds, descending at a speed about 11 centimeters per second, just a little bit faster than a baby that is crawling. It's a very slow pace, but they were able to successfully get that sample and bring it from the edge of our solar system back to us here at that Utah Test and Training Range. You can see our full screen view here of that high altitude view, looking at the parachute at rest on the surface of the desert. This is at the Utah Test and Training Range. It's a wide open expanse here, and the team has this positional info, and they'll be relaying that to our helicopter teams to begin those recovery operations. And what you'll see in a couple seconds here, the recovery team, the recovery crews are responsible for securing the sample return capsule, the landing site around it, and helicoptering the SRC to a portable clean room that's located just next door here on the range. And just a little bit later on, it's going to be attached to a 100-foot long line beneath one of the helicopters, and then will actually be flown to the clean room. This was determined to be the best possible way to transport that SRC safely and efficiently, to get it on a nitrogen purge and maintain that pristine nature of the sample within. As I mentioned, this is an enormous ellipse, 37 by 9 miles. It's a large expanse to cover by car. It's a very bumpy ride out there as you kind of start to make your approach across this rugged terrain. With the helicopters, it will be approximately a 20-minute flight back with that SRC. They take it at a nice slow pace, effectively parading the SRC around, just giving it its last big moment as it is served its purpose officially at this point of getting that sample canister safely here to Earth. Once we actually land and begin those recovery operations, you'll see a lot of team members out beginning to take samples, both air and also soil samples from around the area. These are places of interest for the sample curation team that will actually open up the sample canister in the coming days down at the Johnson Space Center in Houston, Texas. They have a phenomenal sample curation facility there, and these samples from Asteroid Bennu will join a historic collection of other asteroid materials, including samples from the Apollo mission, samples from both the Stardust and Genesis missions, as well as Antarctic meteorites that were collected by our scientists. In the coming days, we'll actually know exactly how much sample we got back from Bennu. The original mission requirement was 60 grams of pristine sample from the asteroid surface. Based on some very clever engineering, the team believes that they have potentially 250 grams, or 6 times that mission requirement, inside. And so we just heard that unofficial touchdown time was at 8:52 a.m. Mountain Time here at the Utah Test and Training Range in Dugway, Utah. If you're just joining us, you see that view right now from one of our high-altitude planes observing our touchdown location. On your screen just above that crosshair is the orange creamsicle-colored parachute that brought us the last part of our journey down to the surface of the Earth. You heard from Jim earlier that that main parachute is about 24 feet across. Fairly large parachute that helped us decelerate on our last leg of the journey. And so we just heard a confirmation, actually, that the main parachute deployed much higher than was originally anticipated. It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected here. Still has touchdown on the Utah Test and Training Range. Team members continue to fly out to this location aboard helicopters. As I mentioned, there are 4 recovery helicopters in total. The mission operations team is continuing to monitor the situation. They're the ones who are relaying us that info about that high parachute deployment, that 20,000-foot parachute deployment. They're going to be assessing the situation from their end here, relaying any possible info over to our recovery teams as they begin to make their trip out to our SRC. One of the first goals once the team gets out there is to safe and stow the parachute. Begin to mark places of interest, as I mentioned, for that curation team to begin sampling. This is all a very well-coordinated machine, very well-oiled machine that operates in tandem. They've rehearsed extensively for this moment. So we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago. But we do not yet have visual confirmation of the SRC itself. The team is continuing to survey the region, looking for that sample return capsule.
Recovery operations. Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments. Helos 1 and 2 will be surveying this region, looking for both that SRC and also eyeing up the region, looking at that parachute that was deployed.
Recovery operations. All of the ground supported vehicles have left rig and are in pursuit of the landing zone.
So some more team members are going to be heading out to that landing zone as well in support of those 4 helicopters that will be the main group recovering that sample. The main helicopter will be actually attaching that sample return capsule once the team has it located and ready to prepare for recovery operations. They'll load that on long line. You can see some, once again, some team members pointing at items on the screen here. We'll hopefully get confirmation in the coming minutes of that SRC location. Tim Preiser pointing at the screen now, wondering if he has any more information for us on where that sample return capsule location would be. We do have visual confirmation of that parachute, as I mentioned. Rich Witherspoon radioing out to the team, and now we have a view from our helicopter of the landing location. You can see the sample return capsule dead center on your screen, that kind of dark gray black object right there. And then just to the right of it, a little bit below, is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter, and you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. I'm sure that is a pleasant sight for the team to see.
Recovery operations. Helo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down through that entry, descent, and landing. Lockheed is celebrating that moment. I'm sure they are breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn, just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REx spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range. So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid Regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze. The surface today was probably a little bit soft, so it looks like it's resting a little bit far off the actual desert. It doesn't appear to have dug in too much with that nose cone from the heat shield. You are here with us as we witness this historic moment. It's the first time the United States has delivered samples from an asteroid to Earth. And these samples will be analyzed for decades to come in laboratories around the world. And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range, and then also make sure that that SRC is safe for our operations team to approach and begin recovery. You can see where that parachute disconnected from the top of that SRC. That is the back shield that you see right there at the very top with that little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range. So what you're about to see happening next is the process of recovery operations. This is a key moment of today's events to actually get that SRC from out in the desert into our portable clean room here at Dugway. It is crucial that we maintain the pristine nature of this sample that we got back from asteroid Bennu. It could hold the clues to how everything around us came to be, from the formation of the planets to origins of life here, so the team understands just how crucial the contents of that SRC is, and they're going to work as efficiently and as safely as possible to get that SRC contained, wrapped up in thermal blanketing, placed in a sample carrying fixture, and then attached with long line to our first helicopter there. It'll then be transported the long journey back here, a much more relaxing flight, I'm sure, for our SRC, to our portable clean room at Dugway. At which point the team members will extract the back shell and remove the heat shield from the SRC. It's served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid regolith out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations. At least from this perspective, I'm not noticing really any drag marks or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by our recovery team and will be passed off to the sample curation team at the Johnson Space Center. As they begin to unload and actually open up the sample canister there, exploring the contents within and making sure that no possible contaminants from the surrounding landing location got into our sample. We're getting a wider view now. We should have the helicopters that have landed nearby coming into view, potentially. The team really taking extra precaution as they approach the SRC. As I mentioned, team member safety is paramount during these operations. There are possible potential areas of concern as the team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC to make sure that it is not outgassing from the batteries within, heating up during that re-entry. We'll also be making sure that there is no live voltage present. And we see a view now from our high altitude plane that has visual of those helicopters landed nearby, just at the northern part of your screen. You can see one of them on screen now. The top of your screen there, it is centered up. There is our helicopter, and it appears that we have our on-scene commander potentially walking over. This is once again our high altitude WB-57 shot of our helicopters landed at the LZ, our landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep. We'll just be observing from this high altitude for the next coming minutes as the team actually will be setting up a camera on the ground for us to observe the recovery operations close up. And a note from one of the team members about the SRC itself. So they have approximately 40 hours. That is the amount of time it would take for any air to get into the sample. As I mentioned before, that sample return capsule is a complex network of piping and tubing inside of it, sort of like a labyrinth-like design, and that is intentional to make it incredibly difficult for any possible contaminants from the atmosphere to get into our sample canister. It's also sort of like a nesting doll, if you will, where it has multiple layers of protection that keep that sample safe within. All of that protective layering, once we get that sample into the clean room, will be shed, and we'll be able to actually access that sample canister within. The main goal, as I said, for today is to get that sample canister on a nitrogen purge. That is to maintain its pristine nature And we have visual once again from one of our helicopters here orbiting around the landing location. You can see our SRC at the bottom left of your screen and its parachute that helped us get the last leg of the journey down. It deployed a little bit higher than we expected, 20,000 feet elevation. Original expectation was at about 5,000 feet. And this brought us down the last leg of the journey after a punishing initial entry into Earth's atmosphere over San Francisco, about 82 miles in altitude, to now resting on the rugged Utah Test and Training Range desert floor.
Recovery operations. Recovery team is in the vicinity, beginning their initial assessments.
So you just heard confirmation from Tim Preiser that the team is beginning to actually approach the SRC for that initial environmental and safety sweep. You'll soon see our on-scene commander, Oscar, Stu Wiley, approaching that sample return capsule. As I mentioned before, he'll be checking for any possible unexploded ordnances. You can see our mission operations team. They have been overseeing all of this morning's events, and they're going to continue. There we go on screen. You can see front and center there, Stu Wiley, our on-scene commander, and right behind him is Victoria team. They are both wearing personal protective equipment, gas masks. That's for their own safety as they approach, as there could be potential outgassing from that sample return capsule's batteries heating up during re-entry. You can see him scanning the region. He is checking for any possible unexploded ordnances, UXOs.
Recovery operations. Oscar is performing the unexploded ordnance survey.
And you just heard that he is in fact doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey, the OSIRIS-REx spacecraft. Finally delivering the sample, he is motioning over to Victoria team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed. A little bit closer. Stu continues to pace around the surrounding area. All over here, the team will collect samples. He'll begin to place flags. You can see in his backpack, he's got a couple flags waving in the breeze. Those will be placed at areas of interest for our team members to sample once they arrive and begin those recovery operations. Victoria is now appearing to take out her thermal and gas reading devices. She's taking an initial thermal reading of that SRC as we speak, looking for it to be at an operational temperature of around 100
Recovery
degrees Fahrenheit.
operations. Lockheed Martin Safety is performing hazardous environment assessments.
And you just heard that confirmation. So she is performing that hazardous environment assessment, checking the thermal temperature of that SRC, as well as taking any kind of gas readings to make sure that we are at safe operational levels. She is also leading over. This is Victoria team from Lockheed Martin. Stu continues to sweep the area around her for the safe operation of our recovery crew members. There are several nozzles, valves around the SRC, and so once Victoria has the clear to approach, she'll actually open up some of those valves and insert a gas reading device within to actually take some temperatures. And you can see off to the left of your screen, Stu Wiley is actually safing and stowing away that parachute that helped take us the last leg of the journey. It's great news that that disconnected from the SRC. That allowed our SRC to rest as it is now here on the surface of the Utah Test and Training Range. It appears with minimal dragging.
Recovery operations. Oscar is safing and storing the main parachute.
So Stu is going to get that parachute stowed, placed away, as Victoria is front and center on your screen, beginning to take some of those gas readings to make sure that we are not outgassing any kind of noxious chemicals that could be present from that battery heating up within the SRC. And Stu is walking back to the team with that parachute. So the SRC battery is comprised of lithium disulfide, and as such, the possibility of toxic vapors exists if the battery packaging has been damaged during entry or landing. Discharging could cause a potential presence of hydrogen sulfide from those batteries heating up, or carbon monoxide. And so that is why Victoria initially had her gas mask on. It appears she has now actually taken it off, so it appears that the gas readings indicate nominal conditions.
Recovery operations, Lockheed Martin Safety has confirmed no hazardous gas.
And you just heard that confirmation, so the safety assessment is successful. Victoria has confirmed that with her gas readings and thermal measurements of the SRC. They'll then go back over, Stu and Victoria, for a team huddle to prepare the rest of the team to begin the recovery operations and actually get this SRC into our clean room here at Dugway and continue the operations. You can see the Lockheed Martin team in the bottom left of your screen, just overjoyed with this moment. This is years of careful planning and preparation leading to this final phase of getting that sample back here to our clean rooms. I'm sure they've been holding their breath all morning, so they're getting closer to finally being able to take another breath and relax as we actually will begin our recovery operations, a key part of today's events. And you might see Victoria approach over and over once again to that SRC to continue to take gas readings. At this point, she appears to be covering up the back shell of that SRC, placing a Teflon cover over. This is where the parachute actually deployed at the top of the SRC capsule, the sample return capsule rather. She'll also be checking for any possible live voltage. And we'll wrap Kapton tape around the two cut cable ends protruding from the back of the SRC where that parachute deployed. You can see her with that covering as we speak, placing it on the back shell. And she has successfully placed that shielding on the back, that Teflon cover. Stu walking around behind, checking the rest of the scene, walking back with the parachute that he now has safely stowed away. And you'll see Victoria opening up a couple gas valves on the SRC, taking those gas readings. We'll continue to do this throughout the whole process. She's also placing covers on those gas vents too to prevent any kind of contamination from atmospheric particles, particulates entering into that SRC. She's photographing the scene as well too. This is to keep careful note of exactly the procedures that she's going through for her team. So the recovery operations will be getting underway shortly now that the team has conducted their initial environmental and safety sweep. Everything appears to be nominal, which is fantastic. We do, in fact, have that SRC on the ground. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
Wow. Thank you, James.
Oh.
Can you believe it?
OMG. Touchdown for science. What a great day.
For the folks at home, this is a huge deal, and they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So this is big.
This is so huge, and we're all breathing a big sigh of relief. Obviously, we're not completely out of the woods here, and we'll be monitoring what's going on and keeping you abreast of everything that's happening. But for now,
wow,
we made it home.
A great job by that Lockheed Martin team safing that craft.
Fantastic work.
What a spacecraft. We have to name her specially.
Yes, absolutely. In that capsule, everything perfect. So while the capsule was making its way to the ground, mission teams
recovery operations, all vent covers are in place.
All right, so we're making progress.
We're making progress.
All right, so while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and nurtured this mission for more than 7 years of spaceflight, and even longer in terms of construction and design. Gosh, wow, amazing.
11 years since it was selected to fly. What a job, folks.
Just fantastic. A lot's happened in 7 years. All right, so let's get an update from where the action started this morning. Sophia, tell us everything.
Okay, firstly, I want to say we are so grateful that the capsule is on the ground and in good hands now. Now, from here, from Wig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island. So, during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast ancient seabed. So the mountains that are peppering along the edges over here, they are very muted colors. It's beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
Wow, thank you, Sophia. And thankfully, we got that great image from the NASA helicopter. Just well done to that team. Thank you for that. So while we're keeping an eye on ongoing operations to prep for the SRC transport, we have a special message from someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey, everybody, congratulations to the OSIRIS-REx team. You did it. You designed it, you built it, and you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth, and it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REx mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic, fantastic news. All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REx moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have 2 of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Sunny Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Sunny, thank you for joining us.
Oh, we are honored to be
super
here.
exciting day. Congratulations.
Absolutely historic. How are you feeling?
Pretty amazing.
It's like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality, and we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, we've both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal,
obvious.
pretty close to exciting and intense, and that parachute opened, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight
The recovery team is performing their safety.
This is a beautiful place. It's a beautiful day this morning. You know, no wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this
hope
capsule
so.
too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So
Fantastic.
you guys will be coming back and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, you know, headed back to Moon and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise woman.
I'm
She's
super
wise.
glad the spacecraft did it, and we'll set the pace and show us how to do it. But I think maybe you'll practice a little bit more before we go, because it's a dangerous environment learning about it.
So much Sunny and Butch, thank you so much for joining us today. Hopefully you'll stick around for more of the show.
Yeah,
all right, congratulations
Thank you,
to
guys.
everybody out there.
Really appreciate it. Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REx asteroid sample return mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look. Wow. Absolutely gorgeous. The spaces here are vast, rugged, beautiful. I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a land landing, as opposed to an ocean landing?
So many of our crews land in the ocean, as you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely gorgeous. Well, this isn't the first time that NASA has visited Dugway, and it certainly won't be the last. Take a look. When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS-REx is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust. Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS-REx. After today, NASA and Dugway are looking towards the future, to the Mars sample return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery operations. Nominal SRC recovery operations have
We're
begun.
getting an update. Okay. All right, nominal SRC recovery operations have begun. Okay.
Darn good.
All right. Okay, so today could not have gone any better. How did it, I mean, in large part due to our amazing partners here with the military, how did it look from your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range, and so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right.
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter. And so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though. Yeah. So close.
So we have a big collaboration at NASA with members from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world, the types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that really allows them to hone those problem-solving skills.
Right, so that's why the crews are so good who come from the Army and the Navy and the Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well, there you go. There you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday. Today is your birthday, and you got a piece of the solar system. How about that?
I don't think I could have gotten a better present from NASA.
No. And this is the rarest stuff we've ever had on Earth.
It is. And I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high, really, and so my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool,
yes.
too.
Yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you so much.
We have a saying at NASA that the only way to reach the stars is if we all go together. The OSIRIS-REx team represents pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway. It's a wonderful base. To have it be a prominent area where this is coming down is really amazing to us.
Well, I'm just glad that this little town is getting noticed.
It's a big rock that has kind of like holes in it because they've been flying through the sky with fire because it goes really fast.
Honestly, I find it really cool because you don't really expect this stuff to happen, in your backyard. But I really wish I could see it, but I don't know. I'm going to try my hardest.
I became interested in the mission because I have the NASA app and I get daily updates on photos, and one day I saw a photo that had that Dugway, Utah titled on it, and I was like, I live there. You hear about exciting things all over the world, and it's cool to hear about, but you kind of never think that you'll be, I guess, directly or indirectly involved with it. But to know that it's just happening here within eyesight is pretty cool. Let's go OSIRIS-REx!
go OSIRIS-REx.
Let's go OSIRIS-REx.
Let's go OSIRIS-REx.
Let's go OSIRIS-REx.
All right, let's go OSIRIS-REx. I love that energy.
I do too.
All right, Jim, you know, you're a planetary geologist. How did you get into this? I mean, these kids are just at the beginning of thinking about what their career might be. I mean, how did you do this?
I think all kids are intrinsically curious at birth. My mother said I was interested in space at birth. Don't know how she knew. But in any event, I think we all are, and we follow different pathways. If you see things as beautiful as we have here in Dugway, here in Utah, you'll be inspired by the rocks and the things in space, like these special samples we've brought back, which are unique being from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest we've ever done, and so we're excited. But I think curiosity is in all of us, and so that's really what it's all about. And these kids are ready to pick up on this energy.
Yeah, we need that future generation. All right, let's get an update from James. James, go ahead.
Yeah, Lauren, so the mission operations team has confirmed that we are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately. So everything was right there, working perfectly fine. We got that SRC, as you can see, successfully on the ground. It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretto, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples, collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually begin to scoop up some of the samples. And this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within. This has been a long journey. It's been an incredible morning to witness this live. Just such a stunning feat of engineering to get that capsule back here to Earth with samples of the asteroid Bennu. This is why we do science, right? To get these kinds of samples, every piece of dust and grain inside that sample return capsule is a PhD thesis waiting to be written. It's a new discovery waiting for us about the origins of the solar system and our place in it. And the vast majority of that sample, more than 70% of that sample, is actually going to be stowed away for future analysis. We did the same exact thing with the Apollo missions when we brought back rocks from the moon. A large quantity of those rocks and dust from the moon our astronauts brought back were stowed away for future generations with the expectation that our technology will continue to improve and improve and improve, and then we'd be able to ask questions that we couldn't even begin to fathom. And now the same thing we'll be doing with the OSIRIS-REx samples that we brought back from the asteroid Bennu. A lot of these will be opened up 50 years from now with scientists who are yet to be born, asking questions we can't even begin to imagine. So our team is just huddling off screen now, and our recovery operations will begin. You'll see a number of team members come out here. They'll be carrying with them a carrying fixture. It's a large metal fixture that has been perfectly designed to have our SRC resting within. They'll be bringing out a lot of thermal blanketing that will be used to protect our SRC during its flight back to the clean room here. Again, we want to make sure that that SRC is safe from any kind of possible contamination from the atmosphere. So they're going to do an excellent job of actually wrapping this SRC up and getting it prepared to transport to our portable clean room. That actual operation of getting that SRC bagged and stowed and ready to go on our long line operations for the helicopter will be a rather quick operation, as you see some team members from Lockheed Martin. Their role is largely finished for today. They were operating a lot of the flight dynamics of that SRC, getting it to the ground, and now they can really just take a step back and relax, catch their breath after all the chaos of the morning. Very exciting moment for all of them, I'm sure, to actually see their creation sitting on the surface of the Utah Test and Training Range. Just massive, massive sigh of relief. So as I mentioned, that actual recovery of the SRC will be a relatively quick process, but a number of our team members, including Dante Loretta, our principal investigator, might remain out on the site where you see that SRC on your screen now. They're going to continue to collect samples. You can see a number of flags placed around. There's some pink flags placed there. There are 4 placed in front of the SRC where the team believes the SRC is potentially dragged along the surface as it came to a rest on the Utah Test and Training Range desert surface. On the back side of that SRC are 4 additional pink flags, and those are our regions for control sampling. We'll actually go and sample all of these regions and compare back to areas we believe the SRC did not contact. You can see additionally, it's a little bit hard to make out with the bright color of the desert, but there are a couple white flags present at the SRC. And these are areas of operation for the team to actually be able to walk up to the SRC with the carrying fixture, place it next to the SRC, and actually begin to bag and stow our sample return capsule for transport to the Dugway clean room. So it's been already just an incredible morning. We're now about an hour past landing of the OSIRIS-REx sample return capsule. Just a few years ago, our spacecraft, our intrepid robotic explorer, was 200 million miles away from us on the other side of the solar system. It successfully captured a sample of the asteroid Bennu, stowed it away, and transported it on the long 1.2 billion mile journey to us here on Earth. We experienced an incredible entry, descent, and landing as this team that you see on screen here, the Lockheed Martin team, a couple hours before our broadcast started, gave the green light, the go command, to actually release the sample return capsule containing pieces of the asteroid Bennu. It then floated on its own through the vacuum of space for about 4 hours before coming in contact with the atmosphere over the San Francisco, California Bay Area, traveling at just over 27,000 miles per hour and heating up to over 5,000 degrees Fahrenheit as it encountered the incredible drag forces our Earth's atmosphere presents. We then slowed down under our drogue parachute initially, which kept us stable during our descent down to the Utah Test and Training Range. And then ultimately, at about 20,000 feet off the deck, we gave the command to deploy our main parachute, that orange creamsicle color parachute that has now actually already been stowed away by our team members here at the Utah Test and Training Range. It's been a really wild journey. Very excited to have our SRC on the ground. And you see a view of our mission operations team observing our recovery team that is already out on the landing zone, taking samples, beginning to actually prepare the thermal blanketing, the protective layers for our SRC, and you can see we're documenting this whole process along the way. And so these operations will continue for the next couple minutes, or as long as it takes to safely store that SRC and prepare it for long line operations to get it to the clean room here. We'll continue to take samples, and I will continue to monitor the situation as we proceed here. But for now, back to you, Lauren and Jim.
Thanks, James. And just a reminder to those watching, we are in an extremely remote location. And so if our signal is breaking up, it's because we're out in the middle of nowhere. So we're doing a great job, all things considered. One other thing that I wanted to address really quickly is that parachute ended up deploying really quickly. Did it not, Jim?
It did. It deployed high, and this is a smart spacecraft. That sample return capsule detected the deceleration rate, and it decided that it was important to get that parachute out to slow her down so we could make this beautiful, safe landing. And that's the way this magical autonomous spaceflight works these days. We adjust to the dynamics of the environment. Again, hats off to the engineers that built those systems in so we could be home safe doing what you can see on your screen now.
With a beautiful landing. All right, Jim, let's actually take some social media questions now. Let's get our first one. All right, at CCSV wants to know, will the sample be quarantined like moon rocks are?
Well, in this case, based on a classification of what we call the planetary protection, These samples will not be quarantined in that way. The first moon rocks came back, they were quarantined for a week, out on the carrier and all that kind of good stuff, came back to Houston again very carefully. In this case, we understand the asteroid, the environment. We measured it with OSIRIS-REx, other asteroid samples from our colleagues in Japan, and so we don't have to quarantine them the same way. We do have to protect them, though, from contamination, and there's all kinds of systems in place by our team to allow us to understand the level of contamination. So what we study in science is the pristine asteroid.
That was a great question.
Excellent question.
Excellent question.
Recovery operations. SRC is bagged and secured in the handling fixture.
All right, you just heard that the SRC has been bagged, and we are well on our way to getting that to our clean room here at Dugway. Wow, fantastic news. Missions like OSIRIS-REx transform scientific pursuits into engineering challenges. Smart, curious people with pursue answers with creative verve and perseverance. This year, Hollywood also had a story about a crowd of people situated around the touchdown point of an asteroid. And, well, we couldn't help ourselves. We asked the cast of Asteroid City to say a few words. All right, well, it looks like we are having some technical difficulties, but that's okay. We'll definitely get you that video. It's a really fun one.
It is.
Scarlett Johansson, I mean, A-lister,
Yes.
Can you imagine? All right, so let's get an update from our field correspondent, Sophia. Sophia, do you have an update for us?
Okay, Lauren, turns out the landing site really is just over my shoulder. It is just so hard to see through the alkaline particulate out here on the landing zone. But you know what? This is all in great hands, and we are just very thrilled that the capsule is doing well today. So I'm able to see one of the helicopters just circling over there. But for those of you who have just tuned in, I am on Wig Mountain, which is overlooking the ellipse, which is the vast landing zone. And earlier today, the helicopters, which were shuttling our teams of experts and our scientists, departed from here via helicopter once they found out exactly where the capsule landed. And now they're off on their recovery process and are doing what they do, which has been a carefully rehearsed process. So, Lauren, I'm going to send it back to you.
Great, thank you so much, Sophia. All right, well, let's get back to that awesome video of Asteroid City. You don't want to miss this. Take a look.
Hi, I'm Jason Schwartzman. I'm Jake Ryan.
And I'm Scarlett Johansson.
Where are you? Asteroid City, Farm Route 6, mile 75.
Hey everyone, I'm Jeffrey Wright. Junior stargazers and space cadets. Each year we celebrate Asteroid Day.
Hey everyone, I'm Maya Hall.
And I'm Rupert Friend.
And we star in Wes Anderson's new movie, Asteroid City.
In the movie, families from across the country gather in a fictional American desert town for a junior stargazer convention.
I heard there's a real-life reason people will be gathering in the Utah desert this September.
The world will never be the same.
What is happening there on September 24th?
September 24th is going to be a historic day. This is NASA's first asteroid sample return mission and the biggest sample return beyond the moon. Shortly before 9 a.m. local time, the OSIRIS-REx spacecraft carrying precious samples of asteroid Bennu will release the capsule into the atmosphere to lower the samples down to the Utah desert, where scientists are anxiously awaiting the return of these materials.
Wow, that sounds like the plot of a science fiction film.
It's incredible that a spacecraft can go to an asteroid.
Grab some pieces of it and then bring them to Earth.
So what will NASA look for within the asteroid sample?
These pristine asteroid materials will be studied by scientists from around the world. We're going to be looking at the minerals. We're going to be dissecting the rocks, looking at it mineral grain by mineral grain to learn more about how the solar system formed and evolved. We're also going to be looking for water to try to understand how our Earth's oceans came to be. And then finally, we're going to be looking at organic compounds, including some of the basic chemical building blocks of life, to try to understand whether asteroids like Bennu could have delivered the building blocks to Earth, leading to the origin of life on Earth and potentially elsewhere. With the data that we obtained from these materials, we're going to be rewriting the textbooks on solar system formation.
Fascinating stuff. But don't Fragments of asteroids land on Earth all the time. Why can't we study those pieces instead of a mission to bring this sample to the Earth?
Yeah, that's a great question. I mean, in fact, the Earth is constantly being bombarded by fragments of asteroids in the form of meteorites. But one of the big problems with studying meteorites is you don't always know where they came from, and it also can be contaminated.
Fair enough. It makes sense that we'd want to study something more pristine.
So how will NASA protect the sample once it's on Earth? And can I have some?
Oh, I wish we could have some of these samples. I wish I could bring one home with me to put on my dresser at home. But the reality is these samples will only be for educational purposes and scientific research. The samples will be transported to the NASA's Johnson Space Center, where they built a special curation facility just for keeping these samples safe and pristine.
This is also incredible. I'm so glad that NASA has teams of people that are searching for the answers to some of the biggest questions, like where did life and water come from? Where did our solar system come from?
I can't wait to see what we learn from the asteroid sample OSIRIS-REx is bringing to Earth. Thank you for all that you do.
This is also incredible.
Thank you so much for all you do.
Well, you just said that name. You just said OSIRIS-REx. That was the thing.
That was kick-ass.
How did you do that? I was like, what is this phrase?
I was like,
OSIRIS-REx.
OSIRIS-REx.
Yeah, OSIRIS. OSIRIS-REx.
Wow, talk about that mega wattage star power.
Scarlet,
Oh
wow.
my gosh. It takes a huge, talented team with profoundly diverse skills to design and execute something as audacious as OSIRIS-REx. It takes years of planning and perseverance to see it through from that initial notepad doodle to a moment when the world tunes in to celebrate a huge success. It also takes leadership, and I'm pleased to say that we are now joined by the director of NASA Goddard Space Flight Center, Dr. Mackenzie Lystrup. Welcome.
Thank you so much. I'm delighted to be here and very happy about the results coming out today.
It is a great day indeed, and congratulations. This is a huge day for Goddard. It must go without saying that you're very proud.
Absolutely. This team is amazing. They've been through so much for so long. Goddard Space Flight Center, the special thing about NASA's Science Center, Goddard, is that we have scientists and engineers working side by side, and so that doodle on a napkin can turn into something like OSIRIS-REx. And scientists like Dr. Garvin here, who's joined us, really help us create a vision with other scientists of how you're going to do the engineering that gets you to this moment that we have today.
And Mackenzie, we have leadership across all domains on this mission, from system engineering to science to accounting to everything. How did your team in Maryland pull this thing off?
Yeah, we have people who have managed multiple parts of missions over the decades. Systems engineering is critical, and it's one of the things that Goddard really brings to the table. And systems engineering means that we take into account everything about the mission, from the science ideas to the launch to orchestrating the landing here on Earth, but making sure that all of the instruments are working together, making sure that the spacecraft successfully interfaces with the instruments and can carry out its job once it was at Bennu. All of that requires really understanding the entire system. So when we say systems engineering, we're really talking about that overarching, holistic perspective that our scientists and our engineers bring to the table. But it's true that we have some of the greatest scientists and engineers working on space missions, and they pull it off every time.
Awesome.
Fantastic. Well, really quickly here, Goddard will be one of the centers that will receive a sample, but who else will receive a sample of the asteroid?
Samples are really traveling all around the world. What I think is very exciting about this mission is that we're saving about 75%. And we're not sending that out yet. We're keeping that in storage for future generations to be able to use more advanced methods and instruments to be able to analyze. So about 25% of that material is going to be headed to scientific organizations all around the globe.
Fantastic.
Unbelievable.
Well, thank you so much for joining us this morning.
Yeah, thank you.
Thank you so much.
Congratulations.
Yes.
There's a big team of scientists, engineers, and so many others here in Utah working to make OREX a success. It should go without saying, everyone here is mission critical, from bus drivers to planetary geologists, helicopter pilots to logistics experts. With all of the natural excitement about the mission itself, let's stop for a few minutes and highlight those in OSIRIS-REx who made it live and breathe. Take a look. Boy, it's really hard not to get a little emotional when you see all those faces. These are a lot of the people that we've been seeing over the last few days, and they're getting their time in the sun. All right, let's throw it over to James for an operational update. Take it away, James.
Yeah, thanks, Lauren. So while we've been kind of waiting for the past couple of minutes here, the team has actually successfully bagged and prepared the sample return capsule for the long line operations. You can see on your screen right now, the SRC is bagged within thermal blanketing, and that metal thing you see on the bottom is the carrying fixture. This will then be actually loaded up into cargo netting and prepared for long line operations. One of our helicopters will take flight, carrying the SRC dangling beneath it. The SRC is going to be stabilized with that cargo netting. There is a gimbal that will keep it stable as we begin the flight to the clean room with our precious cargo on board. You'll notice a couple of tape markers on that SRC as well, the thermal blanketing there. Those are pieces of Kapton tape marking exactly where vents are on that SRC for team members here at the clean room, who will once again do gas and thermal readings once it arrives at the clean room. Just once again making sure team members are safe and secure as we begin to continue those recovery operations, getting the SRC into the clean room. And this is one of the last phases of the process of getting our SRC back and then opening it up, finally seeing that sample canister within and preparing that for shipment tomorrow on a C-17 cargo plane to the Johnson Space Center's sample curation facility. And this was a very quick process. I mean, if you're keeping time at home, this was only maybe about 20 minutes that they took to get out there once they arrived and wrap everything up really quickly once they were given the official confirmation to approach, get everything stored, prepared for those long line operations. This really has become second nature for these team members. They really are able to bag and prepare this SRC. And you'll see still quite a few flags around that area there. Once this SRC is flown away from the region, the landing zone, team members from the curation team will remain on site and continue to take samples of that surrounding area. They also have set up off screen here, you can't see it, but there is a air reading that they're going to be taking actual air samples of the area, atmospheric samples. All of this will be cross-correlated with samples that we actually get back from the asteroid Bennu to make sure that nothing from Earth here at the LZ or beyond got into that sample return capsule. And you can see some of those team members who are going to be taking those samples, once again approaching the location. Dante Loretta is front and center with them. He has that armband on, and on his left arm, you can see it there, as he's carrying his bucket that has all of his tools that he needs to begin collecting these samples. It's a very tight procedure that they have to go through to make sure that they are properly taking these samples. You can see they are photographing the area first, documenting exactly where they are collecting the sample from. They then have a small metal scooper that they'll use to actually dig into the desert surface. It's a bit of a soft surface out there today. As I mentioned, we did have some rain that softened it up, so it should be easy to dig in there, grab a bit of sample, and then they will bag that sample, seal it up, and then send that off to the sample curation team at the Johnson Space Center. Admiring the region as well. It's a beautiful, clear morning there today. We've been rehearsing in a variety of different conditions, including in the middle of the summer where temperatures were over 100 degrees Fahrenheit, much cooler conditions. You can see our team members wearing their UV shirts today. A much chillier morning for them as they are doing these recovery operations. And this process does take some time as they go through and collect these samples. They want to make sure that they are accurately documenting exactly what's present at this landing zone for the team members who are at the sample curation facility of the Johnson Space Center. getting a great aerial view from our NASA helicopter. They've been doing a phenomenal job all morning tracking the action for us, and we don't give them enough credit. We've been training, obviously, all of the science and engineering
Recovery
aspects.
operations. The recovery team is moving the SRC to Helicopter 1 and preparing for long-line operations.
And there we have it. We are going to be moving towards those long-line operations. The rest of the team members approaching that SRC that has been successfully bagged and prepared to be loaded into the helicopter's long line. This will be the last time the SRC takes flight. We had a wild flight this morning. You can see two team members lifting that SRC up. It's about 120 pounds total once you have the SRC and the carrying fixture there together. They're going to be walking this over, preparing it for cargo netting, and getting that attached to the long line for helicopter operations. And as I mentioned, this is the last time the SRC is going to be taking flight. It had a harrowing journey this morning coming through the Earth's atmosphere at over 27,000 miles per hour. It is now being carried carefully by a couple team members here. So quite a deceleration from that initial entry, and really just a wonderful final journey for our sample before it is opened up at the clean room and prepared to be shipped to this to the curation facility at Johnson. And as I mentioned, this view is coming from one of our NASA helicopters. Just like the science and engineering teams have been preparing for this key moment, our NASA helicopter pilots have also been preparing to cover today's events. They're typically down at Kennedy Space Center in Florida, capturing launch coverage from Cape Canaveral. But this past couple months, they've been out here with us at the Utah Test and Training Range, preparing to document today's events, getting incredible footage for us all along the way. You can see those team members have a bit of a hike to carry it to where it is safe operationally. And you can see we have the cargo netting already laid out there. Our representative from Dugway, Jasmine Nakayama, is prepared with that cargo netting. She is going to help the team here get that SRC that has already been successfully bagged up with thermal wrapping into that cargo netting, and you can see the helicopter already there, staged and ready to lift off. The helicopter pilot has actually removed one of the doors on that helicopter so he can lean out and look down as he carefully lifts the SRC off the terrain. We want to make sure that this is a careful, slow process as we safely transport this SRC to the Dugway clean room. And you can see Jasmine is picking up pieces of the cargo netting and beginning to wrap the SRC that has been placed already on the carrying fixture with the thermal blanketing. Team members observing their handiwork of getting that carefully wrapped up. We'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations. SRC is in the cargo net, and all the gear has been stowed in the helicopter.
Great news. Everything sounds nominal for helicopter operations, and in just a few moments we should have liftoff of that SRC aboard the helicopter with that long line attached. Team members clearing the area to make sure that we can safely take off with our helicopter. These helicopter pilots have also been training in tandem with all the team members the past couple months leading up to this key moment. We've practiced these long line operations. We've practiced the flight back to the Dugway clean room. But obviously nothing compares to the real deal. I'm sure they are feeling the excitement. They are feeling the nerves as they know how precious their cargo is this morning that they're transporting to the Dugway clean room. See, Jasmine is donning a helmet, and the rotors are kicking on for our helicopter. Kicking off some dust as they get up to speed there. It is a dusty morning out on the desert. And this will be, once again, a very slow, deliberate operation. We want to make sure that sample return capsule is safe as we are lifting it off. The piece that Jasmine is holding in her hand right now is that gimbal stabilizer for the cargo netting. That will ensure that the SRC is not wildly spinning as we get to altitude with our helicopter. These helicopters can get upwards of over 100 miles an hour speed, but we're going to go nowhere close to that today. We're going to be taking this at a slow pace, making sure that SRC can get back safely and securely to our Dugway clean room. You can see one of our NASA photographers, Keegan Barber, taking some great pictures. I'm sure those will be phenomenal views of the operations that are going on just across the way from us at the Utah Test and Training Range. As soon as these rotors get up to speed, our helicopter will get off the ground. The terrain is a little bit soft today team members were out here yesterday testing out the grounds and had practiced actually landing with some of the helicopters. Those skids on the helicopters got about an inch into the wet terrain. It's presumably dried a lot more today. It's the sunny, clear skies have probably helped us out a bit, so this should be an easy liftoff for this helicopter to get into the air and help transport that SRC to the clean room. Off-screen, team members are presumably continuing to collect samples of the surrounding area, both environmental, soil samples, atmospheric samples. We'll be continuing to do those operations even as we bring this SRC to our clean room. Just a great view here from our NASA helicopter. And in just a few moments, we should have a stunning view of our SRC lifting off the ground. No part of this SRC comes in contact with the helicopter. As I said, it's been safely stored in that thermal blanketing. There's multiple layers of that blanketing, as well as a tarp being placed over it. Now, it is also in that cargo netting, thanks to our Dugway representative, Jasmine Nakayama. She's then attached this whole contraption to a long line that will dangle about 100 feet below the helicopter. And I can see a lot of dust kicking up now. The engine's really revving up on that helicopter, and it is off the desert terrain in the air with the SRC in tow.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And we have clearance to depart the recovery site. This is a key moment of those recovery operations. We're already getting that SRC out of the landing zone and on its way to the Dugway clean room. In just a few moments, that SRC with the long line attached will be lifting off its landing zone. Jasmine assisting with that final part of the lift, and it is now airborne. As I mentioned, a much more relaxing flight for our SRC on its last leg of its journey. We are officially departing that landing zone. Recovery operations will continue out at the Dugway clean room. I see team members waving goodbye. And look at that view. This is a stunning view of our helicopter. This is a long journey ahead. As I mentioned, probably about 20 minutes of total flight time. We may lose signal as we head out there a bit, but for now we have a stunning view of our helicopter carrying the SRC below, and you can see that stabilizer is helping to keep that SRC nice and stable below. We'll continue to track this transport to the clean room, but for now, back to you, Lauren and Jim.
Wow, check out that epic shot. Check it out.
What a ride.
Wow. All right. Thanks, James. The science community has serious questions about asteroids like Bennu for a long time. What are they made of? Do they hold any clues about the origins of life on Earth or elsewhere? And what can they tell us about our past and potentially our future?
It's all about chemistry, Lauren.
It absolutely is. Well, fortunately, Jim, we are joined by somebody who specializes in the kind of chemistry that you'd be hard-pressed to find outside of NASA. Jason Dworkin is the OSIRIS-REx project scientist. Welcome.
Welcome, Jason. Thanks for coming.
And congratulations. What a historic day.
Oh, it's
you
just
must be so relieved.
Fantastic, yes. Relieved, invigorated, excited, and
As we
so
all
much
are.
work ahead of us.
Right.
Indeed, indeed.
Fun work.
Fun work.
Oh, no, epic work.
Epic work. You must be so excited to dig into the sample yourself. But what makes this sample? You know, we've continued to say this is such an important sample from an asteroid. Why is it scientifically significant?
So Bennu is an ancient piece of the early solar system, a leftover component. It's a fragment of what happens when you make planets, and this fragment of rock it contains the ingredients that happen when you make planets, that happens when you make life. Right. So by studying a sample from the leftovers of space, we can study a sample from the leftovers of the formation of the Earth. Look at the chemistry in detail as you can only do on the ground, using instruments that are sometimes bigger than a launch pad, let alone the rock and the spacecraft. So we can interrogate the compounds, the the minerals in fine detail to understand how they interact with each other and how they could have led to the history of the solar system.
And that's forensic science at its best. But I have a question, Jason, because you're an expert in this. So we're going to save some of this sample so that future generations, future techniques, future people not even born can learn from it in the future as we try to look at our place in space.
Absolutely. That's one of the parts I find the most exciting and gratifying, is that the work we do here will be available for scientists perhaps watching now, perhaps not yet born. They can make choices and come up with their own hypotheses, their own ideas, their own new techniques to look at the sample in new and exciting ways, just as we have for the Apollo samples. A woman in my laboratory studied Apollo 16 and 17 samples that were collected before she was born, using techniques that were not invented in the 1970s to then answer questions that were thought of but couldn't be answered. And so, since you mentioned forensics, we also have equipped future generations with the information to follow the chain of evidence from the construction of the spacecraft all the way to the collection now and then the distribution.
Awesome, Jason.
Wow, that is so cool.
Thank you.
Well, thank you so much for joining us.
Pleasure. Thank you.
Thanks, Jason. Good luck.
Careful handling of this asteroid sample is all about getting the most out of the huge effort to visit the object in the first place. Mission planners considered many destinations but settled on Bennu. Let's learn more about why. OSIRIS-REx was designed to retrieve a sample from asteroid Bennu and return it to Earth. So, of the more than 1 million known asteroids in our solar system, why Bennu? First, as a near-Earth asteroid, Bennu is easy to reach. It takes about 14 months to orbit the Sun and comes close to Earth once every 6 years. To get there, OSIRIS-REx was launched in 2016 on an Atlas V rocket with a single booster and a Centaur upper stage. It also got a big assist from Earth's gravity in 2017, allowing it to match Bennu's orbital tilt. The second reason that Bennu was chosen was its size and spin rate. Bennu measures about half a kilometer in diameter and rotates on its axis once every 4.3 hours, which is actually pretty slow compared to many smaller asteroids. This allowed OSIRIS-REx to map Bennu's surface up close, and to match its velocity, briefly touch down, and collect a sample. Before OSIRIS-REx arrived, scientists thought that Bennu's slow rotation meant a low risk of flinging away most of its sampleable material. But shortly after arrival, Bennu was caught on camera ejecting hundreds of pebbles. It turns out that Bennu regularly sheds small particles, but it still had plenty of loose material left on its surface for sample collection. The third reason for choosing Bennu was its composition. We don't know what ingredients were present during the formation of life on Earth, but primitive asteroids like Bennu serve as time capsules, preserving material from the dawn of the solar system. Spectrometers on OSIRIS-REx confirm that Bennu is rich in carbon-based molecules, including organics that are the stuff of life. When the Bennu sample is analyzed, it will help scientists to better understand the formation of the solar system and our own origins. So why this particular asteroid? Proximity to Earth, the right size and spin, and a carbon-rich composition. That is why we chose Bennu. As you can see in the bottom of your screen, that SRC is continuing its transit to the clean room.
Awesome.
All right, so turning our attention back to the rocks in the Bach, I have to ask Jim, how did they get it in here? What is this?
So this is the TAGSAM sampler head. It's about a foot long. It looks like an old Chevy carburetor, but inside is something much more precious. Inside, maybe 250 or more grams of that primitive material from the asteroid. And it has all the gear on it, including samplers on the bottom, little pads to grab sample, as well as the stuff inside that contains the bigger pebbles and all the dust. It even has witness plates that we use to do that contamination control that Jason was talking about. This is the box.
Mm-hmm. This is the big deal right here. And you know, the material went into this box. We've actually got some of what's called simulant here, and this is obviously not the actual sample from Bennu, but it is a good approximation. Is that right, Jim?
That's right. And so what we discovered on this amazing mission was the material properties and the microgravity of asteroid Bennu didn't behave like we totally expected. they behave like a almost cohesionless fluid. And so while I pour this here and they fall pretty naturally, and this is about the amount of stuff we expect to find inside this sampler head, they flowed more like water on Earth than we expected there on the asteroid. This is new physics. We didn't know that was going to happen. And these rubble pile asteroids are teaching us something at every step. In fact, some of these bits, which are simulants here, may behave more like little balls of styrofoam than the kind of rocks we have here. So we're going to learn new stuff by just doing basic characterization of the goodies inside this sampler head.
And one thing I think is so cool is that, you know, on Earth, it poured directly into these other beaker here, but as you said, it acted almost more like fluid.
Exactly. We actually, when we took this sampler head on the TAGSAM, we pushed it into the asteroid, gave it a poke, let loose the gas, and let the stuff flow. We actually penetrated 50 centimeters. That's more than almost 2 feet. So we went deep into the asteroid, fired our thrusters, and backed away with the sample intact in this sampler head. That was cool. We didn't expect that. We expected contact, 5 seconds later, grab the good stuff and come home.
Right.
So dynamic interactions, learning about how these objects work. As you heard from Lori Glaze, this is how we get to understand the worlds that we need for planetary security.
And I've even heard this described as a ball pit. That's how loose the material was when they approached Bennu.
Exactly. If we had kept going, we didn't have that smart spacecraft, all that great engineering, we could have engulfed ourselves in this rubble pile of stuff. Not good. But no crap happened, and we're on the way home, and we have a sample that's coming here to the clean room right here a mile away.
All right, fantastic. Well, now that the team is bringing the SRC back to the clean room here in Utah, what can we expect?
So the next step is really important. We'll wheel that special apparatus that's carrying sample return canister with this thing inside it right to the clean room, bring it in, take off the elements of the aeroshell. That's the thermal protection system in the back shell. We'll take those off and set up the plumbing to get the nitrogen purge on this particular sampler head. That's critical.
All right, that's next. All right, let's get an update from our gal in the field. Take it away, Sophia.
All right, let's put these puppies down.
Lauren, things are much quieter over here now. But for those of you who are just tuning in, this is where the helicopters departed that were carrying our teams of experts that are now having been through a large part of the recovery process today. But really, that's all I have for your updates here from Wig Mountain, overlooking that vast landing zone. But if you do see, we are miles away from the live broadcast hangar, and it took me 30 minutes to get that 12.5 miles, and that gives you an idea of how long it takes to traverse this tough terrain, which is also why the recovery teams chose to use helicopters to get that capsule safely to the clean room. I luckily had a chance to talk to the pilots of those helicopters just the other day, so let's take a look. The OSIRIS-REx sample return capsule just endured a lengthy 3.8 billion mile journey. But the adventure doesn't end once it touches down. The landing zone itself is so large and the terrain so difficult to navigate that the recovery team delivers the capsule to the clean room by helicopter.
Joe's going to be the man hauling the capsule out on the long line. And then Ryan McDonald is another member, and he will be hauling scientists along with myself, the rest of the capture team.
So Ben, can you tell me about the actual procedure of taking the capsule on the long line?
It's a 100-foot long synthetic line. It's got an electrical cord with it. That will hook on the belly of the helicopter. There you go, point it out.
Right here.
Yep, that's the hook that the line will go on. The pilot will lower this hook down to pick up the capsule. They'll fly it back to the clean room, lower it down, and when he lowers it down, he'll hit a little button on his collective. It'll release that hook, and he'll fly away with the long line.
This is not a normal ride. Can you show us how you fly this for this particular mission?
Yeah, so in this helicopter, when we're doing vertical reference, that's what you call it when you have a line on. Now to see the end of the line, I'll be leaning out like this. It's an awkward position, and kind of lean out and look back because my hook's going to be right down in the middle of the helicopter. It will be this button. This button here is the remote hook, and that will keep the line on the belly, but it'll open that little green remote hook when you push it forward.
The experience of these pilots is all a part of preserving this pristine sample of ancient solar system material. And we all cannot wait to see what chemical compounds the capsule holds.
We're now joined by Robert Lightfoot from Lockheed Martin Space, representing the team that built and flew the OSIRIS-REx spacecraft for NASA. Robert, welcome.
Well, thanks for having me. What a great day. Pretty exciting.
Hey, Robert, thank you.
Pretty exciting.
So this spacecraft has many firsts and some unique tech as well. Can you tell us more about some of the new technologies that were integrated into OSIRIS-REx?
Yeah, you know, there's three that come to mind for me. The first is obviously the touch and go sample collector, where we had to come up with what we called the pogo stick. How we're going to hit the asteroid and collect the sample. So that was the first thing. The other thing, we had a natural feature terrain activity that we did that was really associated with, it was kind of a backup for guidance and navigation, but we ended up needing it because when we got to the asteroid, you remember there were very large boulders we didn't expect to see that we had to fly through. And then finally, probably the most unsung part was our digital twin. We created a digital twin for the spacecraft, which, if you remember, this was right in the middle of COVID.
Right.
And so being able to do the sample and use the digital twin to do all the practicing before we took the sample was probably those are the three things that come to mind for me.
And Robert, you mentioned the TAG-SAM, that critical pogo stick, and we heard that it all began with a red cup and some conversations with napkins and things. Can you tell us about that?
That's exactly what happened. It was somebody doing, it was a solo cup and some kind of activity that we did there, and really think about some of the most famous missions NASA has done. That's what we've done in the past. Is we've used somebody sketched it out on a napkin, and the engineers turn it into reality, and then the scientists get their reward.
To use it. Thank you, Robert. What a great story.
What a fantastic story. Well, thank you so much for joining us, Robert, and congratulations again.
Thanks. Really proud of the team, Lockheed Martin team, and everybody for doing it.
Fantastic
Y'all
work.
take care.
Great job.
We're keeping our eyes on ground operations as teams work to secure the SRC, take measurements at the landing site, and get everything ready for its transit to a specially prepared clean room a few miles away. Today's landing is a big day, but to tell you the truth, NASA is starry-eyed about asteroids, and for good reason. Asteroids are time capsules for the solar system and are vital research destinations for learning about our origins and perhaps our futures. While today's events focus on returning bits of the asteroid Bennu, that's not the only asteroid in NASA's plans. Let's take a look at a glittering list of other places we're en route to visit. 1 year ago, on September 26, 2022, NASA's DART mission navigated to the small asteroid Dimorphos and deliberately crashed into it. Dimorphos is a tiny moon orbiting the asteroid Didymos, which is just a bit larger than Bennu and composed of stony material. The DART impact shortened Dimorphos's orbital period by 33 minutes, making it the first full-scale demonstration of asteroid deflection technology. This summer, while the Bennu samples were approaching Earth, technicians in Titusville, Florida were preparing the Psyche spacecraft to visit an asteroid of a different type. Psyche is named after its massive target, 16 Psyche, which is about 400 times larger than Bennu and more than 3 times as dense. The Psyche spacecraft will visit an asteroid that may consist of a significant amount of nickel-iron metal mixed with rock. It will remotely study 16 Psyche's elemental composition, topography, and gravitational and magnetic fields. The mission will provide insights into the formation of terrestrial planets like Earth. Psyche's launch window opens on October 5th. November may be sweater weather for folks in the Northern Hemisphere, but for the Lucy mission, things will just be heating up. On November 1st, Lucy will train its cameras on the main belt asteroid Dinkinesh. It will take pictures while rapidly flying by and test its ability to track asteroids during high-speed encounters. The Dinkinesh flyby will prepare Lucy for its next encounter with the main belt asteroid Donald Johanson in 2025. In 2027, Lucy will begin its long trip through the Jupiter Trojans, 2 swarms of primitive asteroids trapped in Jupiter's orbit that are thought to be the fossils of planet formation. As the weather starts to cool down, hold on to your hats. It's going to be an asteroid autumn to remember. A lot of work obviously went into getting this special delivery to Earth, but our pursuit for scientific answers is just beginning. Joining us now is Danny Glavin, co-investigator on the OSIRIS-REx mission. Danny, welcome.
Thank you. Great to have you, Danny.
It's great to have you.
We got samples.
We got them.
It's incredible.
You know, so Danny, as somebody who looks for the building blocks of life in extraterrestrial materials, what are you expecting to find in the Bennu sample?
Yeah, so I mean, we're definitely looking for the building blocks of life, and we've been studying meteorites that we think look like Bennu. And so I'd fully expect to find amino acids, the building blocks of proteins, sugars, and energy source for life. Nucleobases, right? Parts of the genetic code. So we'll see what Bennu tells us. One thing I've learned from this mission is so many surprises. Sample analysis probably won't be an exception. We're going to be surprised.
So Danny, I want to talk to you about some of the new techniques you're going to use, but I'm going to introduce a guest we have. This little guest here is actually a meteorite from Mars, and you've looked at those.
Yeah.
This is a new one. We know it's from Mars because measurements from Viking and Curiosity tells us that. But it's, you know, it's taking the ride from Mars here that Mother Nature gave it. So can you kind of talk about the techniques you'll use on those primitive materials that we have on the samples from Bennu versus those you use on these meteorites like from Mars?
Yeah, actually, you know, they're going to be some of the same techniques. We've studied Mars meteorites. Of course, one of the challenges with all meteorites is they get contaminated when they get around. You're looking for the building of blocks of life, and, you know, the contamination really makes it hard to tease out what formed in space. That's why this is so special, these Bennu samples. Pristine materials, right? We're going to be able to trust the organic results from these samples. I just can't tell you how excited I am.
Well, so our Martian gives us the training to know that, to be ready for what you have on Bennu, and to get ready for Mars sample return when we conduct that.
Absolutely. I mean, we've been practicing on meteorites to get ready for Bennu, and we are ready.
They're ready.
We're ready. Let's go.
Let's go. And how exciting, a piece of Mars.
Touching Mars?
Oh my gosh.
You'll be touching Bennu.
Well, not with my fingers.
That's right.
Recovery
All right, Danny.
operations. Helicopter 1 is approaching the clean room facility with the SRC.
All right, so you just heard we are approaching the clean room facility. Let's toss to James for an update. Take it away.
Yeah, Lauren, this is the final leg of the journey of the SRC. It has been loaded on the helicopter a few minutes ago with a long line to get those operations to bring it back to the Dugway clean room. And in just a few moments, we'll have a nice view from just outside us here as it comes back over. And I can see actually right now we have a view of that helicopter with the SRC attached below coming into view over the Dugway clean room. You can see this wonderful final view, and because we were able to transport it this way, this was determined the most efficient way to actually get this SRC to the clean room. It gives us a phenomenal final view here of that last flight, truly a parade for this sample return here, and just a stunning view of the Utah Test and Training Range, surrounding mountains, and there's that SRC beneath the helicopter with the long line. There's about 100 foot of that long line there. You heard from one of our helicopter pilots earlier that they do this very carefully. They hang out the window of that plane, or the helicopter rather, to determine the safety of that SRC, making sure that they are continuing to travel properly with this SRC to the clean room. And as we speak, team members are staged and waiting just outside that clean room, ready to get that SRC back on the ground once more. There are team members already in the clean room, gowned up. They've been waiting there all morning. They know what they need to do for this next step to get that SRC in. It's going to actually be wheeled into the clean room. They're going to go through a brief operation of cleaning off a little bit of the thermal blanketing, taking all of that off, and then wheeling the SRC and placing it into that room. They're going to remove the heat shield and the back shell of the SRC and actually get the sample canister out. And you just heard from Jim a few moments ago, the most important next step here is getting that sample canister on a nitrogen purge. And we'll remind you again, that is to keep the sample within pristine, uncontaminated from the atmospheric particles that surround us, getting that sample nice and on that nitrogen purge. Just a great view. You can see it hanging beneath our helicopter there, not spinning at all because of that gimbal that is keeping it stable. Low winds today. And that SRC is bagged in thermal blanketing inside that cargo netting. And in just a few moments, it's going to be lowered down to team members outside the clean room. The first team members to actually approach this SRC once it lands will be wearing personal protective equipment and gas masks once again. They're going to do another safety assessment of that SRC, approaching with those PPE to take gas measurements to make sure that the batteries did not heat up and outgas at all during this short flight. And then once they give the green light, there will be a brief team huddle. And then the next step of the recovery operations will continue. They'll get that SRC onto a small carrying cart, and you can see it being lowered down. The clean room, the top of the clean room, the building rather, is in view, and that SRC is coming down to the ground. Slowly being lowered. Everything about this has been carefully planned out, a very slow process. You can see a wonderful view of the SRC and the cargo netting. That metal piece on the bottom is the carrying fixture that helps team members actually carry this SRC. In just a few moments, the SRC will be back on the ground. Its second touchdown of the day, a much calmer one than we had earlier this morning. And you see two members approaching, grabbing that cargo netting to get the SRC on the ground, and in just a few seconds we will have a release of that long line. And there you have it. The SRC has arrived at the clean room. Claps from the audience in the background there. Very excited to have this back on the ground. And in just a few moments, team members will approach. A very excited celebration. Great to have it on the ground. And this is the last step of the process for today's events, getting that SRC in the clean room. In just a few moments, you'll see team members approaching and beginning to unwrap the gift within. You can see our first team members walking up with that gas mask on. This is once again for team member safety, just to make sure that the operations are continuing nominally, that there are no possible outgassing from the batteries within. The rest of the team will wait for this initial safety assessment before making their approach. And there was some assistance for this step of the process from our team members out in the field. When they bagged the SRC.
Recovery operations. The SRC has been delivered to the clean room facility and is being prepared to transfer into the clean room.
So Zoe is removing the cargo netting now, and she's going to look at those X marks, those tape markers there. They're capped on tape that the team out in the field actually placed on that thermal blanketing. They let her know exactly where the air vents are, the gas vents on the SRC. So she doesn't have to unwrap the whole thing. She can just unwrap that small part and take her gas readings, just to make sure that we're not outgassing anything from the batteries within. She'll take, once again, some thermal measurements just to make sure we're at safe operational temperatures. We don't anticipate any kind of additional heating on that SRC. You can see her opening up ever so slightly that thermal blanketing right at that capped on tape. Taking her readings, you can see another layer of that thermal blanketing there, and then the SRC is safely stored within. She's further unwrapping the SRC. There is additional thermal blanketing. You can see there's a couple layers. There's 2 layers of the thermal blanketing and then the tarp over top everything. She just needs to access that interior part and take her gas reading. You can see her with the instrument now taking initial thermal temperature reading. A nod of the head there. Looks like everything is nominal. And she'll take a gas reading here. You can hear the helicopters buzzing overhead here. The rest of our recovery team just shortly, a few minutes ago, landed nearby. And as we speak, on the other side of where Zoe is right now, there are team members preparing the clean room for the last leg of the recovery operations, getting that SRC inside the clean room and beginning the process of extracting that sample canister from within. Zoe continues to assess the situation here for safety. She is beckoning for her team to come over. It seems like it is safe for the recovery operations to continue, and 2 more team members will be joining her to assist with this next step of the operation. And here come a few more team members as well. Approaching now is Rich Witherspoon, who's been overseeing a lot of the operations out here at Dugway. There's been a number of rehearsals. We have a ground view now. Zoe is cleared to take off her gas mask. Big smile, very excited to get that SRC back here. It appears to be safe to continue the next step of the operations, getting that sample return capsule in the clean room. She's putting away her thermal protecting gloves. The rest of the team is there, ready to begin actually getting the SRC unwrapped and onto a small cart that will be rolled over in just a few seconds. Rich just giving the team an update on the status here. They do these team huddles just to make sure everyone's on the same page with the recovery operations. It is always simultaneous action. Everything is perfectly coordinated like a ballet dance. Especially once they get in the clean room, you'll see some of those operations. They are very well choreographed. And you can see they are bagging it up just a little bit more before they do this next step of the operation of actually lifting it up onto the cart that will then be wheeled into the clean room. Everything has really been thought out in advance, down to the actual material of the gloves the team members are to use in actually handling the sample return capsule. Nylon 6 is a polymer which is very similar to a protein, and so when nylon gets wet, hydrolyzes, it breaks up and releases a compound called epsilon aminocaproic acid that can be seen in some meteorites. So in order to distinguish between the chemistry that we see on Bennu and the chemistry that we see on nylon degradation, we need to make sure that these sorts of classes of compounds are kept away from the sample. So nylon gloves are not to be used. The gloves you see the team members wearing are made out of nitrile, which is safe to be used. And you can see 2 of our team members carrying that sample return capsule over to our clean room, our camera crew following behind, documenting this whole process. And you can see that cart in the background there. This is to help the team wheel the SRC into the clean room. That big metal door there will be open for just a few moments, and the team will wait just for the dust to settle. It'll kick up a little bit of dust, so they want to wait for that to settle and be visually clean, is the way the team describes it, before they continue to wheel that SRC in further, removing the tarp covering that thermal blanketing protective layer of the SRC. And you can see on the other side of the door, the team members for the clean room team are waiting to acquire that SRC within. And one big lift, all 4 members really digging down underneath there, getting that SRC up onto that fixture, a bit of a heavy lift you can see, and we have it successfully on there. There's some padding protecting that SRC as it rests lightly. You can see the white padding underneath the SRC. In just a few moments, teams will await clearance to open those gates, open that door, and get the SRC inside the clean room, getting it on that nitrogen purge. Just a few moments later, a knock on the door, and there it is. The clean room door is opening up. Our Johnson team on the other side waiting for their precious cargo to arrive, and it is wheeled into the door. We have the SRC inside. Just sitting outside the clean room, you can see at the left of your screen with the NASA meatball and the OSIRIS-REx insignia. That is our portable clean room that has been set up here at Dugway for the sole purpose of this part of the operation. This last step of the process of getting the SRC opened up, accessing the sample canister within, getting it on a nitrogen purge, and then actually tomorrow morning, we'll have a C-17 cargo plane flying this precious cargo down to the Johnson Space Center. At the Johnson Space Center, they've actually built a custom clean room for the OSIRIS-REx Bennu samples. As I mentioned earlier, they're going to be joining a historic collection that also includes samples from the Apollo program that were collected at the surface of the moon, as well as samples from Stardust and Genesis, both of which actually landed here in the Utah Test and Training Range a number of years ago, and also some Antarctic meteorites. We will not actually be opening up the sample canister today, so that we'll actually have to wait just a few days, so the team will have to be patient still as they wait for the official opening of the sample canister. But what you're seeing now, a bunch of team members will lift up the SRC for our curation team to reach underneath, scrape off any kind of dirt, and place it back on to our carrying fixture here. All of these samples will then be looked at as well. Any kind of environmental samples that potentially came in contact with our SRC are of interest to the Johnson team, so all of that will be documented for later as the team continues to shed the thermal blanketing layers that were protecting our SRC on its journey. On the long line, you can see a couple team members looking through the windows of the clean room, waiting for their part of the process to kick off as they get the SRC wheeled in. We get a nice close-up view of the SRC here. You can really see how charred it is from that entry into Earth's atmosphere. That is the back shield that you're seeing of the SRC, and the top part there has been sealed off. That is actually where the parachute was deployed from. You can see there's that yellowish-orange seal that was placed on top there where the parachute disconnected from the SRC. A brief team huddle here as they walk through the next step of the operation, making sure everyone is on the same page here as they will lift up the SRC ever so slightly, and the team has these brush tools. You can see one of our curators carrying one in her right hand there. They'll lift up the SRC, and she's going to scrape off any dirt from the Utah desert that was on the bottom. That will actually then be certainly of interest to the curation team as they begin to analyze the sample we got back. You can see they're giving it a little brush. very charred surface of that SRC. That metallic portion below is the heat shield, which protected our sample on its journey through Earth's atmosphere to the Utah Test and Training Range. And you'll see a lift of that SRC for team members to access underneath, checking for any dirt. It doesn't look like we really had any develop. And this is actually great, because what happened was, since the soil was so damp today, we had a little bit of moisture, it was actually a much softer landing, so not as much dust really caked on that SRC. It landed perfectly on the surface of the Utah desert. They're going to place this back down again. Seems like their operations are going perfectly according to plan here. They'll do another lift on the other side just so they can access where the team members were previously holding. And then if all looks good, they will clear this to be wheeled into the clean room. And really just backing up and thinking about this entire journey from where we started this morning. Right before, maybe about 4 hours before we kicked off our broadcast, the team at Lockheed Martin gave the go to release the SRC that you see right here from the main OSIRIS-REx spacecraft. It detached from that spacecraft on its 4-hour solo journey. There's nothing we could do at that point as it entered into Earth's atmosphere, began the punishing entry, descent, and landing, which took us to the Utah Test and Training Range. Out in the field, teams worked to recover the sample, and they actually continued to take samples, environmental and air samples of the region around where we landed. We successfully bagged the sample return capsule in thermal blanketing that you see right there beneath the SRC, that plastic-looking material. We transported it successfully with our long line operations. Big thanks to our helicopter crew today for helping us get this sample return capsule to the clean room. A couple more lifts here you see, and they're going to remove that last layer of thermal blanketing, placing the SRC on its own without any layering onto our carrying fixture. You can see just how charred up those gloves look. A lot of that char from the heat shield getting off on their gloves. You can just see how dark it is. Really heating up. Initially, when we hit the Earth's atmosphere, we were at over 5,000 degrees Fahrenheit. That's about half as hot as the surface of the sun. Quite warm. It's cooled off substantially, so obviously, as it's been transported throughout the day here, and is now just moments away from getting transported into our NASA clean room that you can see on the right of your screen. Team members are all gowned up, and inside that clean room there is a fixture dead center that this SRC will be placed on that will allow the team to be able to gather around and begin to open up this nesting doll protective layer, the SRC, to access our precious cargo, that sample canister within. Again, they want to make sure that everything is clear before they wheel this in. Everyone's ready to go. Everything looks good before they wheel that sample return capsule into our clean room. Just truly an incredible day, and the science that's within these samples is truly hard to fathom right now, just how influential this science is going to be. Keep in mind, these samples are from the origins of the solar system, billions of years ago. They hold the clues to how everything around us came to be. And in just a few short weeks, scientists will begin to analyze these samples and stow away even more sample for generations to come. Future scientists will be able to open these samples and continue the journey of OSIRIS-REx. As we speak, this incredible mission still has not come to an end. Our spacecraft, our intrepid robotic explorer OSIRIS-REx, is now dubbed OSIRIS-APEX, heading to the asteroid Apophis in the year 2029. Obviously, we do not have that sample return capsule or the sample tag SAM, which actually helped us collect that air filter looking thing that helped us collect these samples at the surface of Bennu. That is no longer attached because it's sitting right here in our clean room. But the mission will continue. The team will map the asteroid Apophis in great detail, similar to what we did with Bennu, descending down to the surface, firing its thrusters, kicking up a sample. And as we speak, the sample that it got from Bennu back in 2020 is just moments away from being wheeled into the clean room. The team doing one more sweep, cleaning off those wheels that came in contact with the pavement outside, just before getting this SRC wheeled over into the clean room. Just truly an incredible journey of this mission. 3.86 billion miles total to Bennu and back with this sample. And now it's just a few feet away from our clean room. You can see on your screen too some of the gas coverings to those vent covers that were placed out in the field that prevented any kind of contaminants from getting into the SRC. And as I mentioned before, that SRC is a nesting doll of sorts, very protective, and within there's a complex network of tubing, labyrinth-like tubing, preventing any kind of contaminants from getting into the sample. But the team still wants to get that sample canister on a nitrogen purge. That will ensure that it will stay clean, pristine from any possible atmospheric contamination. It's going to stay on that nitrogen purge all the way through its trip down to Johnson Space Center, where ultimately it will be opened at their curation facility. You can see in the bottom left of your screen our team members inside the clean room all gowned up, and right at the bottom there, that kind of goldish bronze looking fixture is where this SRC is going to be placed for the next step of the operations. This, as everything has been, is a very careful process, choreographed every step of the way. Team wants to ensure that everything is cleared before they wheel that in. We are just moments away from that wheel of the SRC into our portable clean room. You can see in the background in the pink shirt, Jason Dworkin observing. He is one of our astrobiologists from NASA Goddard. He will be looking at these samples along with hundreds of scientists from around the world, helping us better understand the origins of our solar system. The anticipation builds for this final moment. A massive sigh of relief at this part of the way, because we have that SRC now not only on the ground but just inches away from our clean room. The team looking inside there just to ensure everything is good to go. Get a great shot of that NASA meatball and the OSIRIS-REx logo on the doors of the clean room. The operations at Johnson Space Center, once this sample canister is transported there, will be truly a sight to behold as well. In just a few days, we're actually going to get our first science results from the sample within. And as I mentioned, they built a custom clean room at the Johnson Space Center for this very purpose. The team that you see on screen here has been rehearsing at that clean room, preparing for the big event of actually getting that sample opened up and beginning to parse it out and ship it to labs around the world, stowing a lot of it for future generations. Truly an incredible amount of science that we can't even begin to imagine is trapped within those rocks. And I personally am very excited to see exactly how much sample we got back. The original mission requirement was a mere 60 grams. We had an explosive tag event at Asteroid Bennu back in 2020, excavating over 6 tons of material when we contacted the surface and stowed potentially 250 grams of sample within that tag SAM device, that air filter that Jim was just showing a few moments ago. There are also no radio frequency signals allowed inside the building that you see here too. The building is on ordnance protocol. They want to make sure that everyone is safe here, that there could still be active ordinances from the parachute deployment with the OSIRIS-REx spacecraft. We had a mortar fire to release that parachute, that orange parachute that took us the last stage of our journey to the surface of the Utah Test and Training Range. Crew members pacing around inside that clean room, waiting to get that SRC inside. And so when they actually open up the SRC, removing that back shell, the sample canister, they will attach a couple tripod-looking legs to it, these small legs that will allow them to flip it over onto a table nearby. You can see that metal table in the back of the clean room. And at that point, they're going to put it on a nitrogen purge. You can see they're moving that fixture a little bit closer to the door because they're just going to lift that SRC off of the carrying fixture and place it onto the clean room's fixture. It's a quick little transfer, very quick opening of the doors. In just a second here, you can see our team members moving that a little bit closer. The doors are now open. We are entering into the clean room, and that SRC is about to be moved off onto our clean room fixture. Our clean room team members carrying that SRC in, and these doors will be slammed shut just as soon as we can get that SRC fixture out, and there we go. It is in the clean room. The SRC from the desert of Utah, earlier this morning arriving, has been successfully delivered to the Dugway portable clean room. And you can just see just how charred that SRC back shell and heat shield are. A great close-up angle here. You can really see our prized sample return capsule at long last in the clean room. It's hard to fathom that just a couple years ago, this sample return capsule that you see here was over 200 million miles away from us on the other side of the solar system. The OSIRIS-REx spacecraft worked to quickly stow the sample it got from the asteroid Bennu at sample site Nightingale into this sample return capsule. We slammed that lid shut and prepared it for the long journey back. It took 1.2 billion miles to get from the asteroid Bennu after sample collection to Earth's atmosphere. We entered in 82 miles off the surface of San Francisco, went through the punishing entry, descent, and landing, landed in the desert, and now here we have it, the sample return capsule in our clean room. The team's going to move this a little bit over to the center of the room so that they can all gather around and begin the process of removing that back shell and then ultimately getting the heat shield off as well. So what's going to come up next here is that back shell that you see there. The team will remove that, get the sample canister that is within. It's a complex network of tubing to get to that sample canister, and this is also, like I mentioned, a nesting doll of sorts protecting our sample within. They're going to get that sample canister out. They're going to get it on a nitrogen purge. That is our safe point. That is what we're looking to get to today. As soon as we're there, operations for the day will effectively be completed. Tomorrow, the SRC, the sample canister rather, will be flown on our C-17 cargo plane down to the Johnson Space Center, where in just a few days it will actually be opened up for scientists to be able to see the sample within. It's been incredible covering the moments of today, the journey of our SRC from Bennu to the desert of Utah to our clean room. And for now, back to you, Lauren and Jim.
James, your coverage has been impeccable. We could not have done it without you.
Go, James.
So to be clear, the newly redesigned Apex mission will not be touching down on its destination asteroid Apophis. The big reason for that, of course, is that the vehicle's single-use sample collection device just arrived here on Earth, containing samples of asteroid Bennu. After more than hundreds of millions of miles in space, that sample will now travel a few hundred more miles to a specially prepared home where experts intend not only to study it, but also preserve it for future generations. That facility is the purview of our next guest. Eileen Stansberry is the chief of the Astromaterials Research and Exploration Division at the Johnson Space Center. Welcome, Eileen.
Welcome, Eileen.
Welcome.
Thank you.
How about that? Did you check out that all of that cool movement between the clean room and everyone preparing it?
Absolutely. It's so exciting. Anytime you get samples back, and being here today to receive the Bennu samples is a highlight. The team has been extraordinary. The work that all the variety of participants, team members, teammates that work on this mission have been extraordinary. From the flight teams, the mission development teams, operations, science, curation, all working together to bring these samples home to us. And it may seem as if it takes a lot of time getting into the clean room and processing in the clean room, but a lot of that is because of preserving the contamination, the scientific integrity, minimizing the contamination on the samples. Clean room protocol is always slow and methodical to allow any dust or particles that gets generated or any of the debris from the back shell to settle before you do the next step. So all of these steps are very carefully choreographed to ensure the scientific integrity and maintain the pristine nature of these samples.
And you'll be doing, Eileen, when you receive these in your laboratories at Houston at Johnson Space Center, you'll be doing the next phase of that very special curation. Can you tell us a little about that?
Yes, we have a special facility that was designed in particular for these samples to have all of the appropriate materials restrictions to make sure that these particular samples stay pristine for generations to come. As stewards of the scientific value of samples, we manage samples for future generations in addition to the current science that is available on these samples. So the first thing that we will do is bring them into one particular clean room, let it settle, and we will transfer the sample canister from one level of cleanliness progressively to next level of cleanliness to ultimately a continuously purged nitrogen glove box. Wow. So what they're doing here in the clean room in Utah is to remove the contaminating potential of the heat shield and back shell that were charred during reentry, and get the sample canister on purge to have nitrogen continuously flowing through that canister to ensure that there's no earth contaminations that will leak in, even though the likelihood of that is vanishingly small, making sure that there's a continuous nitrogen purge. So that nitrogen purge will stay on the sample canister until it gets into the nitrogen glove box in Houston, where we will start deintegrating the sample canister to get to the precious cargo inside.
Which are inside the sample head, which has...
Yes.
Right, okay. Right.
But there is the possibility of some samples being within the sample return capsule, this capsule here, because the TAGSAM event worked more well than we had anticipated. There could be some sample of Bennu within the sample capsule.
Wow.
And so we will make sure that that sample also gets identified and safed to maintain its integrity here, so that it also retains its value.
Wow.
Amazing.
What an opportunity. We may have more goodies than we thought.
Yeah, we thought.
Jeez, Eileen.
Well,
Good
Eileen,
job.
thank you so much for joining us today. We've loved having you.
Right, really, Eileen, congratulations. Way to go.
Thank you, and we're so excited.
Your whole professional life has been planning for a future event, and then suddenly that day arrives, like today, which is probably a perfect segue to be bringing up something that may come as an unexpected surprise to mission fans. Today may be the conclusion of flight operations for OSIRIS-REx, but the mission is not exactly finished.
After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astro Materials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.
Jim, OSIRIS-REx collected its samples and is bringing them back to Earth for analysis, like we've all watched today. But how else is NASA planning to analyze its other samples?
So, as you heard from Eileen, OSIRIS-REx in Houston. We'll start the sample preparation around hundreds of labs later. It's going to be fantastic. We also sometimes bring our laboratories to the samples themselves. Curiosity rover. She's carrying a huge payload, not unlike those we'll use in laboratories here. Sometimes we go to new places to actually bring the labs to study samples that we can't bring home. That's our new wrinkle.
And on that note, when I consider how many places there are to visit, I'm aware that a guy like you is probably weighing all of the choices, about where to go. So speaking of which, you are the principal investigator for a new mission called Da Vinci, which for those at home, principal investigator is basically the big guy in charge. So what is this mission about?
So Da Vinci is a mission to Venus. You can see it in the morning sky, and we haven't been back to the Venus atmosphere and all the complexity and how that formed and evolved literally in a generation. So together with a very big team, it's not just the PI. I mean, Dante is the gold standard PI for all of us, but with our team, we're going to bring a spacecraft with the kind of instrumentation we'll be using on the samples from Bennu and from Mars to the samples in the atmosphere that will tell us about the assembly of that atmosphere, whether Venus had oceans for how long, and come under the clouds and see the mountainous regions and their chemistry for the first time in history. And so we're excited to pick up on the great news from this mission, OSIRIS-REx at Bennu, and some Mars exploration, and take that forward to Venus so we'll get the next generation interested in our sister planet.
So everybody stay tuned for that one. So Jim, you've also been the PI of several previous missions. Put yourself in Dante's shoes. How would you feel today?
Dante must be both overwhelmed and overjoyed. Yeah. He's probably, as my wife says occasionally about me, beyond words. And he's been waiting literally his professional lifetime for this. It's here, it's happening, the science is going to flow, they can't miss. Honestly, I am sure Dante and his team are just sitting on pins and needles waiting for the transfer to Houston, all that stuff Eileen said, so we can get to work. This will be epic.
And Jim, not only are you the PI of Da Vinci, but you actually had a hand in OSIRIS-REx as well.
Well, way back in the dark mists of 15 years ago, we were all wondering how we can sample things as hard as asteroids like Bennu. And people like Dante and others had generated the idea we were all talking, because we wanted to think, how do we sample the solar system? Cruise to the moon, great. Giant sample return systems to Mars, fabulous. But these small bodies are also important, and they've been a priority for our National Academy. Cometary nuclei, asteroids like, of course, carbon-bearing ones like Bennu. So when those folks got together, we were all in conversation, and they proposed mission ideas, and some of us were able to participate in very small ways to help them get these missions going. It's just a thrill to see them succeed so well.
Especially after 15 years. As you can see, Jim is a wealth of knowledge. So on that note, we're getting questions from around the world about this thrilling mission. Let's take our final questions of the day. All right, at Oatmeal, today is my birthday. Can I have some of the asteroid sample? It would mean a lot.
Well, you heard there's other birthdays today, too, including the Colonel.
I think Oatmeal saw that it was also Colonel Harwell's birthday.
But as Danny Glavin and Jason said, the samples from Bennu are for scientific research, education, inspiration. They'll be used, for future generations even, as Eileen said and Jason said. So, unfortunately, we can't give you Bennu. We can give you pictures and up-close vantage point like we've given you today, and as the science is done by the science community, and so you'll be part of that, and you can write proposals to work on samples if you have a neat new instrument you want to try. So stay tuned.
Stay tuned. And I understand, Oatmeal. I also want a piece of that sample, yes. But we got to, we can't. All right, Jim, let's take one more. All right, at Electromanicia, I hope I got that right. What questions are we hoping to answer by studying the samples from asteroid Bennu?
Well, fantastic question, and there are many. It's all in the name. So we want to look at those building block chemistries of the earliest solar system. It's all eradicated here on Earth. We have to go to places like Bennu or other asteroids like it to get those records. So we're going to look in the deep time to understand our solar system from those chemicals. We're also going to look at how we use a real asteroid stuff to understand what we see of other asteroids through telescopes and flyby spacecraft. That's the ground truthing, or the asteroid ground truthing that we do. We're also going to look at resource potential. These asteroids contain bound water in minerals. Those are really cool. You can get the water out. That's neat. Also, interesting distribution of metals. So this is a really exciting opportunity to put that all together and also understand the mechanical behavior of these objects. They're rubble piles held barely together flying through space. So we're going to do all of that and answer questions we haven't even thought of yet. Dante's team will invent the questions for the future from what they do with these samples.
Fantastic. All right, I think we have time for one more. Let's take a look at horrors of coding. Is there any worry of possible bacteria or virus from the sample, regardless of the clean room?
So that's a very good question. And of course, the team, and you heard from Jason Dworkin and others, have been thinking about that for a long time. We think these types of asteroids and the materials from them are not life-bearing. And they're not life-bearing, and so we have classified this mission as a certain class of planetary protection. So we're not expecting any true life-bearing biological elements to be a part. But the fragments of organic chemistry, carbon-bearing stuff that you heard Danny Glavin talk about, the building blocks of life that got it all started in all the places it is here, but also maybe elsewhere, really important. So we don't expect to see any of that. We've contained the contamination. You see what's going on now in the portable clean room and at Eileen's place back in Johnson Space Center. So we're very optimistic. No worries about that stuff. We're good here.
So I think we talked about this a little bit, but I think one thing people are maybe wondering, or even maybe a little worried about, is could this sample contaminate Earth? Are we at risk of something catastrophic?
Literally so vanishingly small that no one would rightfully bet on anything like that. This is space, rock, and dust from a time so far ago that's been baked in the space radiation that wouldn't be good for any any living thing, sorry. We're all organic. And so it's been sterilized by being in space, in effect. And we do the same thing when we go and sterilize stuff that we'll bring back from planets like Mars. So.
How long is this next process going to take? You know, we're in the clean room now, we're going to go to Texas. How long is this all going to take before we start getting some results?
So in the next few weeks, in the next couple of weeks, by October 11th, we expect the team in Houston, Eileen's team, and together with Dante's team, will have done that first proper containment and understanding all the possible sources of contamination, so they can document those for the future and also make sure they're through all those gates that Eileen was mentioning, so the samples are protected from anything from Earth, so they won't be contaminated. Then they'll do some first characterization with all these great machines they have in Houston, and we'll start talking about what they get by the end of October, going into the Christmas time. And by the end of January, I've been told the science team meeting, the sample leaders will start reporting to all of us what's going on.
Wow, that is soon. And you heard that unboxing day is October 11th. Did I hear that
That's
right?
It will be a Christmas party for samples.
Okay, that's right. So Jim, I'm struck by how these last few minutes compared to the last few years. You know, here we just saw human hands wheeling precious scientific, cargo at walking speed, when just a few hours ago it was barreling through Earth's atmosphere.
Exactly. We went from cosmic velocity to velocity smaller than an ant would use to crawl across a table to pick up a crumb. And so that's the speed of science. To get it, the engineering flies, cosmic velocity, sampling, all that great dynamics, and finally now the careful, methodical, snail's pace to get it done right so we preserve it. I mean, this is like geoarchaeology of samples from a place that's not Earth. Very special.
Yeah, absolutely. The sample return capsule isn't done traveling, of course. Once it gets stabilized on what's called a nitrogen purge to ensure everything remains dry and uncontaminated by intrusive gases, the entire apparatus will be loaded aboard a C-17 cargo plane for a flight on its way home to Johnson Space Center. Once it arrives, scientists are ready to start working on vital research on this extraordinary sample of the asteroid Bennu. But that airplane ride and the research plans waiting for it on the other side starts tomorrow. For now, the OSIRIS-REx sample return capsule has completed its solo journey of nearly 4 billion miles, landing in the Utah desert, and is now in the expert care of our on-site sample curation team. But we're not out of the woods yet. We did mention this nitrogen purge.
That's right.
So
we have to carefully contain this so we can do that work and literally, really transform knowledge for all time. This is the thing that we dream of, and Dante and his team 10 years ago were thinking of that. Transformational knowledge that will change how we think of ourselves.
And we couldn't let you go before we share something fun. So we just delivered a sample of the asteroid Bennu back to Earth, but the UPS can also deliver fun stamps of the actual asteroid Bennu sample return. Let me turn that over so you can see it on this side. How fun is that?
So we have brought an asteroid first-class delivery from OSIRIS-REx to Earth, and our Postal Service here in the United States is issuing stamps to build on that inspiration so they can deliver our packages for us.
How exciting. I know, everybody needs to get some of these. These are really cute.
Yeah, I want one.
I would like one too. As we're wrapping coverage here at the Utah Test and Training Range, let me remind you that this is not the end of the story. Next up is our post-landing news conference scheduled for 3 p.m. Mountain Time, 5 p.m. Eastern Time on NASA TV, presented live right here on nasa.gov and other streaming sites. You can also find mission updates on X at NASA and on the web at nasa.gov. That's all the time we have for today. Jim, it has been a pleasure sharing the stage with you. We did it.
Way to go. Thank you, Lauren, for having me.
And a huge thank you to all of our guests for joining us today, and a warm thanks to all of you out there for watching us. Here are some highlights from today's exciting landing. Special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space.
We see.
PDL milestone, we have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. Disconnecting from the back shell, we'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations, SRC is in the cargo net, and all the gear has been stowed in the helicopter.
Special coverage of America's